Hello student, welcome to my channel Learn Physics. Today I will be discussing the gravitation of class 9. This discussion includes the law of gravitation and numerical based on it. Therefore this video will be very important for you for foundation of NEET, main and advanced. Please like, share and comment on the video. Okay, now let's start. Now first of all, statement: every two particles in the universe attract each other along the line joining the two masses, and magnitude of force of attraction directly proportional to product of their masses and inversely proportional to the square of their distance of separation. Suppose, look at this, m1 and m2 are two masses separated by a distance d. So the force act along the line joining the two masses. Okay, and magnitude of this force F directly proportional to product of mass m1 and m2. Now product of mass m1 and m2 means m1 into m2. So this is the m1 into m2. This means if mass of one body double, then force double. If mass of two body double, then force becomes 2 into 2, 4 times. If one mass double, this mass 3 times, then force becomes 2 into 3, 6 times than earlier. Okay. Now next, the force is inversely proportional to square of the distance, that is F proportionate 1 by d square. That is, if distance double, then force of attraction becomes 1/4 time. If distance becomes 3 times, then force of attraction becomes 1 by 3 square, that is 1 by 9 times. If distance between them is 6-fold, then force of attraction becomes 1 by 36 times. Okay, now combining these two relations, we get F equal to capital G m1 m2 divided by d square. Okay, where capital G is called universal gravitational constant. Universal gravitational constant. Okay, now we define capital G. Look at this, if m1 equal to m2 equal to 1, d equal to 1, then by putting this relation in this equation, we get F equal to G into 1 by 1 square. So this is the G. Therefore G equal to F. Therefore universal gravitational constant is the magnitude of force of attraction between the two particles having unit mass separated by unit distance. Its value is equal to 6.67 into 10 to the power minus 11 Newton meter square kg to the power minus 2. This value first determined by Cavendish with sensitive instrument. Okay, now next. Now condition when Newton's law of gravitation will be applicable. Look at this. If size of the body is negligible in comparison to their distance of separation. Now universality of Newton's law of gravitation. Number 1, the Newton's law of gravitation is applicable for two terrestrial object as well as two celestial object. Okay, number 2, Newton's law of gravitation is applicable for terrestrial distance as well as celestial distance. That is, it is applicable for small distance as well as very large distance. Okay, next, this law is independent of physical state of the bodies. Number 4, it is independent of medium. That is, the force of attraction between the two particles is same in air as well as same in water medium. Okay, last, this force is independent of electric field, magnetic field, etc. Okay, now look at this. A small object M is at a distance small d from the center of the earth. The force of attraction on the body by the earth is attracted towards the center of the earth, and force of attraction on earth by the body is directed towards the small m. Now the magnitude of force of attraction F equals to G capital M, mass of the earth, mass of the body, divided by square of the distance of separation. Okay, this force of attraction same. The force on small m is equal to force on capital M. Okay, now acceleration of small m. Look at this, a small m. This is the F by small m. So this is the G capital M small m by d square by m. Look at this and this cancel out. So this is the G capital M by a d square. This is equation number 1. Now acceleration of earth, look at this, acceleration of earth, this is the am. So this is the F by mass of the earth. So this is the, look at this, G capital M small m by d square into capital M. Now this and this cancel out. So this is the A capital M, this is the G small m divided by d square. This is equation number 2. Now divide am by A capital M. Look at this, A small m, that is acceleration of the small m, by acceleration of capital M, that is earth. Look at this, if you divide this by this, look at this, this is the G capital M by d square divided by G small m by d square. Look at this and this cancel out, and this cancel out. So we get capital M by small m. Look at this here, greater than 1. Mass of the earth by mass of the object, this ratio is greater than 1. Therefore acceleration of small m greater than acceleration of capital M. That is, acceleration of small object is greater than acceleration of earth. That is why the body falls on earth's surface. Okay, understood? Now I will be solving numericals of Ncert and exemplar. Now look at this Ncert example 10.1. We have to calculate the force of attraction between earth and moon separated by the distance of 3.84 into 10 to the power 5 kilometer. Here mass of the earth is 6 into 10 to the power 24 kg. Mass of the moon 7.4 into 10 to the power 2 kg. And capital G is equal to 6.67 into 10 to the power minus 11 Newton meter square kg to the power minus 2. Now here distance is given in kilometer, so it should be converted into meter. Now we know 1 kilometer is equal to 1000 meter. So look at this, kilometer is converted into meter by multiplying this factor by 1000. Okay, now look at this, here 10 to the power 3 and 10 to the power 5, so 10 to the power 8. Okay, now Newton's law of gravitation, F equal to capital G, capital M, small m divided by d square. Now put this value in this equation. So here F equal to, this is the 6.67 into 10 to the power minus 11. This is the capital M, 6 into 10 to the power 24. And small m, this is the 7.4 into 10 to the power, this is the 22, divided by, this is the d square, that is 3.84 into 10 to the power 8 whole square. Okay, now look at this, here 10 to the power minus 11, here 10 to the power 24, here 10 to the power 22. So look at this, 24 plus 22, 46, 46 minus 11, 35. So look at this, this is the 10 to the power 35 and this is the 6.67 into 6 into 7.4 and look at this is the 3.84 whole square. Look at this, 10 to the power 8 whole square. So 10 to the power 16. Look at this is the 10 to the power 16. Therefore, look at this into this, so this is the 40 into 7.4 divided by 3.84 whole square, this is 10 to the power, look at this, 19. Okay, now look at this is 4 into 7.4 divided by 3.84 whole square into 10 to the power 20. Okay, now if we divide this, we can get almost 2. So 2 into 10 to the power 20 Newton is the force of attraction between Earth and Moon. Okay, understood? Please like, share and comment on this. Okay, now numerical 1 of Ncert exercise. If the distance of separation between the two objects is reduced to half of its present value, what will be the gravitational force of attraction? So look at this. First of all, initially the force of attraction F equals to G, capital M, small m by a d square. Okay, this is equation number 1. Now here mass of the two objects same. Look at this. When distance of separation reduced to half, the force becomes F dash. So this is the G, capital M, small m, and this is the d by 2 whole square. Okay, understood? Now this is capital G, capital M, small m divided by d square by 4. So this becomes 4 into G, capital M, small m divided by d square. Now look at this is the this and this is the F. So this is the 4F. Therefore gravitational force of attraction becomes 4 into F, that is 4 times the initial. Okay, understood? Next, we know that gravitational force is directly proportional to their masses. So why not heavy masses fall faster than the light masses? Now look at this, the gravitational force of attraction is mutual force of attraction, that is the heavy mass attracted by small mass by the force F. The small mass also attracted by heavy mass by the same force F. So this is the mutual force of attraction. So whatever be their mass, the force of attraction same. Why does heavy mass does not fall faster? Look at this, the acceleration of heavy mass, this is the AM, this is the force by mass. And look at this, the acceleration of small mass, this is the force by mass of the small body. Now look at this is the AM by A small m. So look at this is the F by capital M and this is the F by small m. So look at this here, F by capital M into M by F. Okay, understood? So this and this cancel out. So this becomes small m by capital M. Look at this. This is the less than 1. This is the small mass and this is the heavy mass. So ratio between them is less than 1. So look at this here. So here A capital M less than A small m. Therefore acceleration of heavy mass is less than acceleration of small mass. That is why the heavy mass does not fall faster than the light mass. Okay? Please comment on this video. Now we have to calculate the force of attraction of 1 kg mass on the earth surface. Here mass of the earth is given and radius of earth is also given. And we know G equal to 6.67 in 10 to the power minus 11. Okay, so look at this, the gravitational force of attraction between this and this is the G capital M small m by this is the R square, because the mass 1 kg is on the earth surface. So distance of separation between earth and small mass m is equal to radius of the earth. Now put this value in this equation. So we get this is the 6.67 into 10 to the power minus 11. This is the 6 into 10 to the power 24 and this is the 1. Okay, and R is the 6.4 into 10 to the power 6 whole square. So look at this. Look at this. This is the 10 to the power minus 11 and 10 to the power 24. So 10 to the power 13. So look at this. This is the 10 to the power 13. Look at this. This is 10 to the power 6 whole square. So this is the 10 to the power 12. Okay. Now here 6.67 and into 6 and here 6.4 whole square. Okay. Understood? Now 6.67 into 6 is equal to 40. So look at this. This is the 40 into, look at this, this and this cancel out. This is 10. This is the 10 by 6.4 whole square. So this is the 400 divided by 6.4 whole square. This is almost 9.8 Newton. Okay. Understood? Next. Now numerical 16. The mass of earth is 6.4 into 10 to the power 24 kg. Mass of sun is 2 into 10 to the power 30 kg. And distance of separation is 1.5 into 10 to the power 11 meter. We have to calculate the force of attraction between sun and earth. Now the formula is F equal to G m1 m2 by d square. So look at this, the force of attraction F equal to, this is the G m1 m2 divided by d square. Look at this, G is the 6.67 into 10 to the power minus 11. M1 is the 6.4 into 10 to the power 24. M2 2 into 10 to the power 30. Whole divided by, this is the 1.5 into 10 to the power 11 whole square. Okay. Now look at this. Here 10 to the power 30, 24. Now 30 plus 24. This is the 54. 54 minus 11, 43. So look at this. This is the 10 to the power 43. And look at this. Here 10 to the power 11 square. So 10 to the power 22. So here 10 to the power 22 and this is the 6.67 into 6 into 2 divided by 1.5 whole square. Okay, understood? Next. So this is the, look at this, this into this is the 40 into 2 divided by 2.25 into 10 to the power, look at this is the 43 and this is the 22. So this is the 43, so this is the 43, this is the 22, so 43 minus 22 is the 21, so this is the 21. Therefore, this is the 8 by 2.25 into 10 to the power 22 Newton. This is the 3.5 into 10 to the power 22 Newton is the force of attraction between Earth and Sun. Okay, please comment on this video. Now exemplar 3. The force of attraction between two masses m1, m2 separated by the distance d is f. Now if mass of both the bodies be half, what will be their force of attraction? So look at this. Initially the force of attraction was, this is the g m1 m2 by d square. This is the initial force of attraction. Now the final force of attraction f dash, this is the g, the mass is half m1 by 2, this also m2 by 2, divided by d square. So look at this, this is the 1 by 4, 2 to 4 into g m1 m2 divided by d square. So look at this, this is the 1 by 4, this equal to this equal to this. So this is the f. Therefore force of attraction becomes 1 by 4 times. Okay, next. Now exemplar numerical 9. The force of attraction between two masses m1 and m2 separated by the distance is f. Look at this, f equals to g m1 m2 by d square. What will be the force of attraction if mass of each body be twice, keeping distance same? So distance is same. Now look at this, here f dash, this is the g, this is the 2m1, 2m2 divided by d square. So look at this, 2 to 4. Therefore this is 4 into g m1 m2 divided by d square. Look at this, this is the f. So this is the 4f, is the force of attraction between them. So force of attraction becomes 4 times the initial. Okay. And now exemplar question 16. What is the source of centripetal force by which the planet revolves around the sun? The gravitational force of attraction between planet and the sun provides necessary centripetal force for the motion of the planet. Look at this, look at this. This is the path of the planet, this is the sun. So this force, the gravitational force F equal to g m1 m2 divided by d square provides centripetal force for the motion in its orbit. Now next question, exemplar 17. If gravitational force between earth and moon vanish, what happens on moon? Look at this, if centrifugal force, that is force of attraction between the earth and moon vanishes, the moon moves tangentially from its path. Okay, many thanks for watching this video. I hope this video will be extremely helpful for you. Please like, share and comment on the video. And don't forget to subscribe my channel to learn physics easily. Okay.